Welcome. So my name is Dario Tranquitella, and I'm here today with Luca Barze, and I'm technical advisor at CLASTIX, and we are addressing multi-tenancy in Kubernetes. So Luca, please introduce yourself.
Hello to everyone. I'm Luca Barze, and I'm a pre-sales engineer based in Italy for SUSE.
So Luca, would you
So,
like to introduce our agenda for this recording for
for
this
sure,
session?
for sure. Yes, for sure. So, during this session, myself and Dario will speak about a solution to manage multi-tenancy within our Kubernetes environment. So, this solution is made by CLASTIX and integrates really well with our solution, which is Rancher. So, this is the agenda of our talk. We will start defining what is multi-tenancy. Then we will show what can we achieve with multi-tenancy within Rancher, and it's the limits of the Rancher approach to multi-tenancy. Then we will show how capsule can help, and we will also do a small demonstration of how the integration made by a product of CLASTIX, which is called capsules, uh, integrates with Rancher. Okay, so what is multi-tenancy? Multi-tenancy is a paradigm, an architecture, in which we have a system which is shared between multiple entities, between multiple tenants. This is why it's called multi-tenant. So what is a tenant? A tenant can be, for example, an individual who is using a shared resource, can be, let's say, uh, an organization which shares a system with other organization, can be a group of people who share the system with our group of people, and so on. So, generally speaking, tenant is a group of identities, as you see here. And if we want to have a system shared between different entities, as you see in the slide, we should have some characteristic of the system. We should give resource control um, to our tenant. We should give them a good isolation and security so that different tenants cannot see the resource of the other, and most importantly, they cannot modify the resource of the other. So if for example, I'm using a system and Dario is using the same system, I cannot modify what Dario is doing on the system. Okay. And as you see, we have to be careful about cost control, and we should use some kind of enhanced governance on our resources. Okay, so thank you. But why do we care about multi-tenancy in 2023? As you see, if we can manage our system for different entities from a single pane of glass, okay, we can share our system between different entities so that it's easier for us to manage the system. It's not that every entity should know how to manage the system, how the system work in details, okay? But some things will get much more easier if we manage our system centrally, okay? And as you see here in the slide, we know that sharing in our infrastructure leads to efficiency, because we can, if we are the tenant which is using the platform, it's easier for us because we just have to use the platform. We don't have to go into all the details that are needed to manage the platform in a specific way. Okay, and our infrastructure will also be more reliable, and the performance will be better because there will be a dedicated group of people who are experts that will take care of everything instead of us. And if on the other side, we are the expert people that are managing the system, we can open a new line of business. Okay, so we can give our system to other person, maybe less expert than us in managing the system in detail, and so that we can offer them a service, a centralized service, and we become a managed service provider. So we open a new business model. Okay, so how does it work in Kubernetes world? As you know, Kubernetes has become a de facto standard for new applications. Okay, and how does multi-tenancy works in this new de facto standard way of deploying application, which is Kubernetes? So in Kubernetes, we have a few primitives that works really well to isolate resources between different tenants. And we have identities defined on our Kubernetes platform, and as so that we can interact with our Kubernetes cluster as a human or machine with service account. We can define different permission and role in our Kubernetes cluster on different resources. Okay. And what are the Kubernetes resources? You see that here. So we can have Kubernetes API objects or resources from the operating system, network, storage, and so on. As we will see later in more detail, within Kubernetes, we don't have a specific um, base access control on every of these aspect based on our identity. So we are a human, we are a machine, we have a specific credential, and this credential is not really specific on any of these objects that you see in the lower part of the slide. Okay, we will see this more in detail later. Okay, so let's start to explain this concept. So if we have our Kubernetes cluster, the most important concept for multi-tenancy, the most important resource for multi-tenancy is the namespace. Okay, so we have namespace. Namespace are a Kubernetes resource that is used to give different identities rights on different resources in your Kubernetes cluster, and so that you can think that you can you can split your Kubernetes cluster in different namespaces, and you give each tenant different right on different namespaces. Okay, this can for sure be true, but you, as we will see, you will also have to go through a wide range of technical and operational challenges. You see a few of them written down there. Okay, so you also have to go through resource management, configuration management, isolation and security, scalability, networking. So it's not easy starting from namespaces to have, let's say, a full and working multi-tenancy environment in a single Kubernetes cluster.
It could sound cumbersome because it seems that we're saying you cannot achieve multi-tenancy in Kubernetes. But well, that will be true, but it's not entirely true because if you think about that, we got namespaces, but we got all the tools to create our own stronger multi-tenancy solution that is overcoming the limitations of namespaces. And as you said before, we got the users, we are identifying the people who are using our platform. So with that said, we are almost done because we are just missing, between inverted commas, the resource control and the resource isolation. So keep in mind that all the modern Kubernetes clusters, they are already offering some APIs, and referring to the resource quota and limit range. So with resource quota, we can try to say this tenant in this namespace cannot consume more than 20 or 50 Kubernetes pods or cannot consume more than 50 gigabytes of memory. And with the limit range, essentially, we are ensuring that all the workloads that are going to be deployed in the namespace of my tenant, they got a limit. Because obviously, if we are not setting limits, it means that the containers are going to run with no limits at all. So not having limits, it could bring to exhausting all the resources of the underlying operative system, so CPU, memory, storage, and so on and so forth. But besides the resource control, we have to take also, we need to talk about resource isolation. And with resource isolation, we are addressing the resource allocation in a fair way, but also we are talking about security. Because with the namespace boundary, we know that with namespaces, we can create a logical partition of our Kubernetes cluster where the tenant owners can create their own deployments and their own workloads. And then we need also a way to enforce the rules, because what happens if Alice, Bob, or Charlie, any tenant owner of a different tenant, is able to manipulate and to manage the workloads of another tenant? We need the RBAC. So with the RBAC, we are ensuring we are creating a perimeter of rights for the tenant owners. And then we need to talk also about network policy, because with network policy, we are creating an additional boundary from the network layer. So it means that workloads deployed in one tenant cannot start pinging or communicate with other workloads in other tenants. And last but not least, also we got the pod security, because with pod security, we are preventing the privilege escalation. Because, we have to adopt always, or where it's possible, a first security first approach with zero trust. So it means that with zero trust, we cannot allow running pods that are privileged, or rather mounting the underlying host path. So reading the kubelet certificates, or reading the secrets and also the volumes of other applications from other tenants running in the same node. So we have to enforce these pod security policies, these pod security standards, and at the same time, also we need to enforce the node selector. So we have to be sure that our workloads are going to be placed only on a specific subset of nodes. We could have different tiers where we are saying this tenant can run just on this specific hardware that is shared across other tenants, and preventing the workloads from the tenant boundary to run in the control plane nodes, for example. So we got multiple challenges here, because keep in mind that we got all our API primitives to build our solution, but there are some limitations. So the limitations, there are plenty, but I decided to go just for these most prominent for ones. So it's the an inability to list namespaces, because in Kubernetes, essentially, we are configuring everything through RBAC. So with the RBAC, I can say I can manage this namespace, but I cannot manage the list of namespaces, because or I can get all the lists of all namespaces, or rather, I cannot get the list. So there is no solution like select all namespaces where the owner is Addis. It doesn't work like that way. So it's a huge limitation, because I cannot list all the namespaces, because otherwise I could create a surface of attack for exfiltration. So the ability to understand which other tenants are running in that cluster. And same applies also for the cluster scope resources, because if I'm creating a platform, this platform is creating a set of rules to be sure that the tenant can use just specific storage, ingress, runtime, or priority classes. These are other primitives, really cool, because with that you can create various tiers of the priority and the resource allocation. And last but not least, we got some issues with the resource quota. So with resource quota, we can enforce a predefined amount of resources that a namespace can consume. But in a multi-tenant environment, we cannot just use a single namespace. We could have maybe an organization, a tenant, so a division that is run by multiple users, and each user, that could be user, client, customer, whatever you want, each one is requiring one or more namespaces. So using a single boundary of the namespace is not really feasible. It works maybe in theory, but in the practical way, in the pragmatic way, doesn't work like that. So there is no boundary for to let the resource quota to address the enforcement, so the quota at the tenant aware level. And last but not least, also we have to be sure that we are not able to start a privilege escalation and noisy neighbors. So it's really challenging. I'm not saying it's impossible, but in the past we were ending up creating multiple clusters for each tenant. And I'm not saying that's wrong, but I'm here to try to explain you how you can overcome that thanks to Capsule and the really well working integration with Ranger. So let's talk about Ranger, Luca.
Yes. So, well, what is Rancher? Rancher is a powerful platform to manage different Kubernetes clusters. So, with Rancher, we can manage easily a number of different Kubernetes clusters. And with Rancher, we obtain a centralized console for managing all of our cluster and all of our applications which are running within each cluster. And with Rancher, we can address a lot of operational and security challenges of managing our multiple Kubernetes cluster. Okay, so Rancher is a platform that make easy to for us to install and manage a Kubernetes cluster, and with Rancher we can install and manage different Kubernetes cluster. Okay. So within Rancher, we have two ways to pass that we can follow for the multi-tenancy within our Kubernetes environment. The first one is shown on the left side of this slide. So that what does it mean? It means that with Rancher, we can create and manage a lot of Kubernetes cluster. It's not an issue to manage different Kubernetes cluster with Rancher. So that we create, I don't know, 3 Kubernetes cluster, we have 3 tenants, and we give each tenant the full, let's say, administrative rights on a single cluster, so that we can overcome in easily the limitations that we had for the multi-tenancy on a single Kubernetes cluster that we just spoke about. This is kind of true. It is not totally true. Well, the first reason why this is not true is that you don't optimize very well the resource consumption, because, well, if you can share a single environment between different tenants, then it's easier to optimize your resource consumption. Okay. For example, if myself and Dario are using the same environment, maybe when my application will consume a lot of CPU, then Dario, for some reason, will not, so that I can we can optimize our resources. So the resource consumption will be overall less. And this is a point. The second point is that if we are we have to manage a Kubernetes cluster, then we have to create some key component of Kubernetes, which are the etcd and the control plane. So someone calls them the master node of Kubernetes. Okay, and these are, let's say, fundamental resources of our Kubernetes cluster. They are the most critical components of our Kubernetes cluster. Okay, so if we have to create a Kubernetes cluster just for myself, then we will need to add on top of our Kubernetes cluster at least 3 nodes, okay, 3 etcd nodes and control plane node. This is the starting point for our Kubernetes cluster. And so if we have to manage, I don't know, 10 entities, then we have to manage 10 entities for our 10 tenants that have to use our system. Then we will have to add 30 nodes. Okay, if we have 100 tenants, then we will have to add 300 nodes, just as a starting point. Okay, and this is a problem that we can address with a different integration that CLASTIX made, which is called Kamaji, as you can see there. And with Kamaji, we can share our master nodes, let's say our etcd, our control plane, and so on, between different tenants. Okay. We will not speak about Kamaji integration during this talk, okay? And we already spoke of this integration, and well, there is a YouTube video that is linked here. If Dario want, so yeah, yes, you can find it here. Okay. What we will speak about is the second approach that we can follow, that is shown on the right side of this slide. Okay. So within Ranger, we have a resource which is called project. And what is a project? A project is an ensemble of namespaces, okay? They are a Rancher-defined entities. They are not a Kubernetes entity. They are a Rancher-defined entities. And with project, you can make a group of different namespaces, and then you give each tenant the rights on a single project, okay? So within a project, you have different namespaces, as we already said, and with Rancher's project, you kind of obtain a multi-tenant environment. The main issue is that, as we already said, projects are a Rancher entities. They are not a Kubernetes entity. So if you use a command line tool like kubectl, for example, or any other tool which is not the Rancher itself, then this other tool does not know what a project is. Okay. And so, for example, if you do the same thing um, that Dario talked about before, so if you do the list of the namespaces, okay, and let's suppose that you have the rights only on a single Rancher project, so on a few namespaces that live within your cluster, and you want to list all the namespaces of your cluster, then you will see all the namespaces of the cluster, not just yours namespaces. Okay. So Rancher projects are good. They are really good within Rancher. We have the necessity to add something more to manage something also for the command line, and something that integrates between our project and our command line. And this is where capsule comes in.
Yeah,
So
absolutely. Thanks for introduction, Luca. And what I really love about Kubernetes is the fact that I'm enabled to create more complex structures because it's like playing with them Legos, you know. So I got my Lego and I can create my infrastructure, and it's really cool because in the end, with Legos, I can also try to overcome some limitations. And I think that Capsule is, I'm not saying that Ranger projects they are limited, but they are addressing a specific use case, so grouping together some resources. And as you saw, we got a sort of context boundary between the Ranger project and the capsule tenants. And that's perfect because in the end, if you think about, they're pretty similar, but in the capsule jargon, we are ending up with the users that are tenant owners that will be enabled to create namespaces on their own. So self-service is really, really important. I know that it's really challenging because from the security standpoint, creating namespaces could be a problem because I need to replicate a set of rules like the RBAC, like the pod security policies, network policies, and so on and so forth. But that's really the disruptive approach because in the end you can imagine, let's say I got 8,000 of tenant owners, and each one is opening a Jira ticket. So your system is going to be overwhelmed. Instead, with self-service, you are decreasing the operational toil. So with Capsule, keep in mind that we are addressing security first, then we are addressing also the self-service, and we are removing the operational toil of managing such a platform. And also keep in mind that Capsule is an operator. So it means that we got a definition that is the tenant definition. And according to that definition, we are constantly reconciling the resources. So if we got a violation or if we are missing a resource, Capsule is much quicker compared to human because we are watching for events from the Kubernetes API server. And also, we are not breaking any Kubernetes user experience because Capsule is able to work using the Ranger UI or is working with the kubectl. And I'll try to describe in a nutshell the architecture of Capsule. So we got our Capsule controller that is the one that is checking constantly the required resource to address the multi-tenancy design that you implemented for your own tenants. And then we got a Capsule policy engine that is reading the definition of the tenant and is allowing or denying the request from the tenant owners. So essentially, in the end, you're ending up with a manifest that could be even GitOps ready, and they are ready GitOps ready because it's just a bunch of YAML lines, and you can distribute them to your tenant, to your workload clusters, and in the end, you're automating everything. So in the end, you're reducing the time to market to deliver a new tenant. You're reducing the time also to offboard a tenant. And in the end, you're ending up with an auditing system because all the policies are recorded. So you can play safe because the boundaries are designed according to your organizational needs, and you can export all the data to be sure to check what happened in your tenants. So this is the user experience. So in the end, Capsule can be used from UI, as I said before, but keep in mind that we all know that developers, they love the CLI, or at least I'm a different kind of developer and I really love the CLI. So in the end, I don't need any third-party plugin or maybe a different binary. I will always use kubectl, and with kubectl I can create a namespace, and that namespace, since I'm Bob and I'm part of the Capsule CLASTIX IO group, my namespace will be binded to the tenant. So as you can see here, I'm Bob, I'm part of this tenant, and my namespace will be attached to this tenant. Keep in mind that don't worry, we are going to have a sort of demo at the end of this introduction. So with the capsule tenant definition, what I can do is to isolate the resources. That's one of the pillar of multi-tenancy, and I can control the resources. As you can see here, we got plenty of resources that we can control. Keep in mind that we got a huge documentation website where you can find tutorials, but keep in mind that you can engage with us in async mode, so using the preferred social network or even emails to get in touch with us so we can help you to understand the benefits of multi-tenancy and also how you can achieve that. So let's try to understand what could be the problem here, because in the end, let's say I got multiple tenants, and for each tenant, I want to be sure that they are allowed to run just a specific storage or ingress class or priority class or runtime class. This is just an example, so it really depends according to your needs. And you can imagine that if I got just a few tenants, I can create my policies on my own. But once I got more and more tenants, the burden is really overwhelming. So having an automation where Capsule or any other tool is ensuring these policies is really, really important. Also because we need also to be sure that the tenant owners, they can just run their own assigned ingress or priority classes. So in the end, instead of creating policies and policies, what you can do is to have your tenant definition and you're overcoming this complexity. Capsule, keep in mind that it's an open source project and is backed by CLASTIX, the commercial company behind that. And so far, we saw several use cases. And this is just in a nutshell one of the most used ones. And I want to talk rather about the real use cases because so far we were able to see companies using Capsule to offer a sort of Kubernetes as a service solution for their own tenants. But we saw also different use cases that are really, really interesting, like the simulation of war scenarios, where they are using Kubernetes as platform to deploy these simulations where a real console is connecting to, and this console is used by a human operator and is doing training on the job. So instead of triggering a real war, there is a simulation, and the operator is operating the missile systems connecting to a Kubernetes cluster. And that's really cool because in the end, they were able, this use case, to went from a sequential, from a serial approach to a parallel simulation at the same time. Or we saw also some customers that were able to create a deep learning platform as a service backed by capsules. So they were running one huge cluster, and each tenant was a set of developers where they were training their own models. So keep in mind that capsule is pretty flexible, and thanks to multi-tenancy, you can achieve a lot of stuff. Besides, obviously, the basic managed service provider business where you're offering the underlying compute layer of your infrastructure to let tenant run their workloads. So let's try to understand in a nutshell how it works, because we got capsule that is combining with ranger, and that's perfect because I'd say keep in mind that I was one of the developers working in this integration, and it worked pretty well because we got the ranger projects with the capsule tenants that are combining together, and with ranger projects we got a UI that is pretty simple to use. And with capsule tenants we are offering the namespace as a service. So in the end, I just need to grant the permissions from Ranger to the developers. And then we got the Capsule Proxy. Capsule Proxy is one of the add-on that is overcoming the limitations of the Kubernetes API server. And thanks to the Capsule Ranger add-on, that is the first component that we need to install in the tenant cluster, essentially we are ending up with a effortless, smooth integration between Capsule, the capabilities offered by Capsule, and the Ranger ones. So I think that it's showtime. So let's try to have a real demo. So we are all here to see this in action. So keep in mind that in this shell, in this window, I'm showing you how it works. I'm accessing a Ranger cluster using the admin user. And as you can see here, we got our local cluster, and I registered a tenant cluster. You can have multiple of them. So for the sake of simplicity, we are just using one. And this is my tenant cluster where I got multiple projects. As you can see here, I got the project oil, the project default, the project system, and I got multiple nodes. In this case, just one, but you can get the point. And obviously, I got plenty of resources like the storage. For example, I have multiple storage classes. I got the CFFS and then I got the standard. So you can bring your own. So I could have multiple storage classes, one according to each tenant, or rather, I could have even tenants that are not allowed to create storage because storage in the end it could be a bit expensive. And the same applies also for other resources like the networking ingress class. So a pattern that we saw is also to try to allow developers to expose their own applications using a specific ingress controller. So with the ingress controller, it means that one tenant can just use Nginx and another tenant is using HA proxy and so on and so forth. The design here, the multi-tenancy layer you would like to implement, it really depends according to your needs. And keep in mind that also Capsule has been installed here. And as you can see here, we should be able to see the Capsule configuration and the tenants. So as you can see here, I define a tenant that is named oil, and I assign some permissions. So this is the jargon, this is the YAML definition, and I don't want to go through the definition because we got the Capsule website and we got plenty of tutorials. So I'll try to be brief as much as possible. So we for this tenant we are saying that the unique ingress class that the tenant can use is nginx, and then we are defining also some node selectors. It means that all the nodes, all the workloads of this tenant, they must be assigned just to a specific subset of nodes. This is really cool because with the node selector essentially you can decrease the noisy neighbor effect. So in the end, it's like having a specific subset of nodes, and the network is pretty ensured from the quality of service. You don't have any workload running there consuming the bandwidth. And also keep in mind that we are adding some namespace options. So for each namespace the tenant owner is going to create is going to be automatically assigned to the project. So this is the ID of the project, but from the annotations with the project ID and also from the labels. Last but not least, also, we got the storage classes. So this tenant can just consume storage classes that are assigned to the standard storage class. And as you can see here, I already have some namespaces because I just want to give a try before the demo. They are working, but we are going to get through later. Also, since we are here, I want to show you in the capsule system namespace that we got several add-ons. So we got the Capsule Ranger add-on that can be installed. Then we got the Capsule Proxy and Capsule Controller Manager. So these three Helm releases have been installed using the CLI, but in the upcoming days, we are going to expose them through the marketplace so you can install Capsule and configure that directly from the apps catalog. So it's going to be even more a tighter integration with Ranger. So this is the admin. That's pretty straightforward. Let's try to see how it works from the tenant perspective. So I got this window. It's an incognito, and I'm going to log with Keycloak. We integrated with our identity provider here, and I logged in as Dario at CLASTIX.io. So I am the tenant owner, and as you can see here on Ranger, I've been entitled to use the tenant cluster. And if I click on the tenant cluster, as you can see here, I got my dashboard where I got the project and namespaces. And since I'm part of the oil project, it means that I'm part also of the oil tenant of Capsule. And I have my own namespaces. But let's try to see also how it works, because if I remember, we are entitled to use some specific storage classes. So if I access here storage and I click on storage classes, take a look here. I can get just list of my entitled storage classes. And that's really awesome because we are overcoming the limitations of the Kubernetes API server. And the same applies also for the networking with the ingress class, where I can get just list of my ingress. But furthermore, there is something more interesting because, as I said before, I'm a geek, I'm a nerd, I really love the CLI. And let's see how it works, because Ranger is really cool because in the end, we are getting with a single pane of glass for multi-cluster management. And in this case, with Capture, we are supercharging also with multi-tenant capabilities. So I'm ending up with a single entry point. So I'm using CLI. I can download that. So it's something pretty trivial if you already know Ranger. I'm using right now the CLI from the web UI. And take a look here. If I issue kubectl get namespace, I'll end up with just list of my own namespaces. So oil dev, oil QA, and oil staging. And what's really cool is that if I issue kubectl create namespace oil demo, the namespace is going to be created and automatically binded to my tenant. And Capsule will ensure all the required resources like the RBAC, the policies required by the multi-tenancy design that we implemented and we designed. Furthermore, what we can do is to issue kubectl get storage classes, and I can get list just of my storage classes assigned. And the same applies for the ingress classes. Ingress oops, ingress classes. And also, we just need to wait. Maybe the connection is not working, but it's working. And the same applies also for the nodes. So if the tenant is defining a set of nodes where the workloads are going to be placed, with kubectl I'll get nodes, I'll get list of my nodes. So in the end, in a nutshell, with capsule, you are getting the best from Ranger, and you're putting in place also a set of policy engine to address multi-tenancy, and by creating a sort of virtual slice of your cluster. You don't need to create multiple clusters. You can use one or more clusters that are going to be shared by multiple tenants. And with that said, you're ending up with a optimization from the source perspective, but also addressing security in the first place. And with that said, also keep in mind that you can configure some permissions from the tenant level. So you can have multiple tenant owners, but take a look here because we are granting to this user, to this Dario at CLASTIX.io, the list and list capabilities to ingress classes, nodes, and storage classes. So in the end, you can have different users, and each user is entitled to see or not some resources, even modified, because we got multiple use cases and we don't have enough time to talk about that because multi-tenancy is really a vast topic. And with that said, I think that we can continue our slides presentation. So keep in mind that Luca was really kind to talk also about Kamaji, and Capsule is right now is going to be present in a matter of weeks. I'd say it's going to be presented as available extension in the catalog. But also keep in mind that Capsule is just addressing one specific use case of multi-tenancy, and it's a soft one. We got another use case that is the hard one, and it's backed by Kamaji. And Kamaji is offering hosted control planes. So control plane running as pods, and that's really cool because in the end you're ending up with clusters that can be provisioned on the fly and are really lightweight. But also, please, Luca, also big news between CLASTIX and Ranger.
Yes. So, we are in the process of certifying CLASTIX as a certified solution partner for MSP and for enterprises. Well, we concluded the process, and so that you can refer to CLASTIX for this when you have this necessity. And we will have in a short time a blog entry in SUSE for the solution of CLASTIX made on top of Kamaji, as we talked before. And well, yeah, I think that
Yeah,
that's it.
we have the Q&A session, but it's a virtual session. So if you
So
have
yes,
time, yes, you can. If you're in
yes.
real life, please. Classics has its own booth. And with that said, I would like to thank you for paying so much attention to our solution.
Thank you.
Thank you. Bye bye.
Bye. Bye. Bye.